Hi there. So let's cover functions. I'm going to break this up into multiple different videos for you to try to keep them short so you can have easy access to what you need. Okay. All right. The definition of a function. A function is a rule for a relationship between an input or an independent quantity and an output or a dependent quantity, in which each input value uniquely determines one and only one output value. And we say the output is a function of the input. All right, so here's where we get started really. The function notation that we use is the function name, and the function name is usually f, but it can be whatever you want it to be. So I know we talked later about how sometimes I'll use V for value or P for price. It can literally be anything you want, but the typical one that you're used to is the F, okay? And the input is always related to the X value. If you think about a coordinate plane or a Cartesian coordinate plane, and you have the X line and the Y line, the X is always the independent or the value that decides, and the input's one that always decides what your output is. So its function of X is equal to the output, which is also Y. Now keep this in mind that f of X, you can say f of X or function of X, is equal to Y. We're going to need that here in a little bit as well. And each of these values, the value of X and the value of Y, corresponds to an ordered pair. And that ordered pair is just always in this same method, X comma Y, and there's a parenthesis around both of them. X is always your input or independent variable, and Y is always your output or dependent variable. It's dependent on what X is. Okay. Here's an example. The number of days in a month is a function. So function, so the number of days in the month, so I'm going to do just what they're saying, days of the month is a function of the name of the month. I can even write name of the month. I'm going to even make it broader than they have it. All right, so what that means is, and they took it down further to where you can say days is equal to function of month. It means the same thing. And just to make it simpler, is just D is equal to function of M. And those are just abbreviations to help you, make it smaller and just easier to deal with. And getting you used to using the abbreviations. So what this means is if I can choose any month, and I'm just going to go with June, it's my birthday month. So the function of June is going to give us 30 because there's 30 days in the month. If I say function of October, that's a month, then you're going to get 31 days. Now, we can go in that direction to where the function of the month is equal to the days. However, we can't say, well, what's the function of 30? Well, you're not going to get June. You're going to get lots of different ones. Same thing with function of 31. You're going to get January, October, December. There's just, that's not a function at that point. In this regards, the function of June, you're going to get one and only one answer. And that's what a function is. All right. A function P of N gives the number of police officers. So police officers is just being abbreviated to P. So the number of police officers, and I can just go off of what they're saying here, in a town in years after 2000, well, then what, that's just a definition. What does P of 5 equal 300 tell us? Well, they already told us P is the number of police officers. So the number of police officers, Sorry, my pen. In years after 2000. Well, N is, if you'll notice, it's P of N. So the N is 5. So it's 5 years after the year 2000. So 2000 plus 5 is the year 2005. So the number of police officers in 2005, and then you're going to get the output is 300 or was 300. And that's it. You're going to need to be able to do this on your homework as well as on our next exam. All right, using the tables shown, evaluate G of 3. We're just going to start with that one. So if you follow these steps exactly, I promise you it's going to work for you. So if we're evaluating, let's go up here. A is evaluate G of 3. Well, what does that mean? That means when N is 3, when N is equal to 3, what is G of 3? Okay, well, then I'm going to come up here towards N. N is 3, so I need to find 3. Here's 3. What is the function when N is 3? 7. So G of 3 equals 7. This does not need to be put in sentence form. That would be your answer. The next one is determine N when G of N is 6. So B, G of N is 6. What is N? Well, I'm going to come up here where G of N is. G of N, which is what they're telling us, is equal to 6. So I just need to find 6. Well, here's 6. What's N when G of N is 6? 2. N is equal to 2. But there's another one. Here's another G of N is equal to 6. And what's N then? 4. So N equals 4. So your answers for this would be G of 2 is equal to 4, is equal to 6, and G of 4 is equal to 6. And that is your answer. Let's do a you try. So please pause the video and attempt this on your own first before you watch me do it. Okay. The function K of M is given by the table below. Evaluate K of 4. So for A, K of 4 is when M is equal to 4, what is the function K of 4? Well, we're going to have to come up here where M is equal to 4. So M is equal to 4 here. What's the function when M is equal to 4? It's 51. So K of 4 is equal to 51. All right, for B, determine M when K of M, the function K of M, is 8. What is M? So I have to come up here where K of M is because they're telling us what the function is K of M is. So I have to find 8. Well, here's 8. What's M when K of M is 8? 0. So M equals 0. Therefore, the function K of 0 is equal to 8. So when M is 0, the entire function is 8. 0 is your independent variable or your independent number that you're plugging in to get your dependent 8. Okay. Given the graph below, evaluate F of 2. So I need to stop for a second and make sure you understand that this is the X the X line. That's your independent line. It decides what your F of X, your function of X is. And your function of X is always equal to Y. So it's your Y line. All right, because remember we have an X and Y coordinate point. All right, so they're telling us that f of 2, so I'm going to come over here, a is f of 2. So that means when x is 2, when x is equal to 2, what is y? Well, I have to come along my x coordinate here and find 2. Here it is. Well, then, all right, great, there's 2, but we need to find it on the line. Where does x cross at 2 on the line? It crosses right here. Okay, where is that in relation to the y line? And I can just take that and go over here and point. It's 1. So when x is 2, y is 1. So the function at 2 is equal to 1. All right, I'm going to erase this part real quick just so that you have it cleaned up for the next. Oh, hold on a second. Just so that this is cleaned up for our next part. All right, the next one, B, they're telling us what our y is, what our function of x is. So they're telling us that f of x, which is also equal to y, is equal to 4. What is x when y is 4? What is x? This is a question you should be asking yourself. What is x when y is 4? Okay, so I'm going to have to go on my y-axis and find 4. All right, anything above this x line here is positive. So I come up to 4 and find the points where on the line where it's at 4. So there's one there, and there's another one over here. Now I need to find out how, where those are corresponding to the x values. So I can just drop it down just like I did the y one. Well, that one's at -1. So that means when y is at 4, x is at -1. And so I can just take my function of x is equal to y here and plug that in. When x is -1, y is 4. But I have a second one as well. I have one right here where y is 4. Where is that corresponding to x? Drop it down and find out. It's at when x is 3, y is 4. So I can write it the same way. F of 3, when x is 3, y is 4. You are not always going to have 2. It's based on where it's hitting on the line. Okay, that's all it's based on. So you need to find out where that point is, where it's happening at x. So that's your independent variable. That's the one that goes inside the function of x. And then the y is 4 because that's where we were looking from, because they already told us the function of x is equal to 4. We just need to find those points. Okay. All right. So I want you to pause this and attempt this on your own, and then come back and watch how I do it and compare your answers to mine. No one's judging here. This is just to make sure you understand it. So please pause. Okay, so the first one is evaluate function when x is equal to 1. So A is function of 1. And that means when x is 1, what is y? Because remember, function of x is equal to y. So here's my x, and here's my y, or my function of x. It's the same thing. All right, and they're telling us what x is. They're telling us x is 1. So right here's 1, but it happens to also be on the line at that point. Well, if you'll notice, y is 0 at that point, because here's a -1 and here's a 1. Y is 0 here. So what is y? Well, y is 0. So the function when x is at 1 is equal to 0. Okay. The next one is B, determine x when f of x is equal to 1. Well, that's also y is equal to 1. So now I have to come up here to where my y is equal to 1 and find it on the line. Well, here's a point on the line, and here's a point on the line where y is equal to 1. Okay, so now I have to do a drop down to find out where that's hitting on my x-axis. So I'm going to drop it down and say, oh, well, that's 0. So the function at 0 is equal to 1. So when x is 0, y is 1. And the other one is, here's my second point, that's when x is equal to 2. So the function when x is equal to 2 is equal to 1. Okay. All right. Given the function k of t is equal to 2t plus 5, evaluate k of 8. So they're using, instead of x, they're using t. So I'm going to rewrite k of 8, I'm sorry, k of t. Oh my gosh. Sorry, y'all. Eraser. Don't do that. All right, k of t is equal to 2t plus 5. All right, but they're telling us that t is already equal to 8. So k of 8 is equal to, everywhere there's a t, you're going to plug in 8. So 2 times 8 plus 5. And now we're just going to solve the right-hand side only. Please do not think that this is multiplication. It's not. It's just representation of a function. We're only solving the right-hand side. So 2 times 8 is 16, plus 5 is 21. So the function k, when t is 8, is equal to 21. That was A. For B, I'm going to rewrite the function again. K of t is equal to 2t plus 5. But they're also telling us that k of t is equal to 1. K of t, these two are the same thing. So that means that these two are the same thing. And we can set them equal and solve for t. So 2t plus 5 is equal to 1. Solving for t, I'm going to subtract 5 from both sides, and I get 2t is equal to -4. 2 is attached to t by multiplication, so I have to divide both sides by 2, and I get t is equal to -2. Okay, so the function is k of t. So k of -2 is equal to 1. They want to know what t was. All right, pause the video, attempt this one on your own, and then come back and see how I did it. Given the function g of m is equal to 5m, pardon me, plus 17. And they're wanting us to evaluate when m is equal to 9, what is the function? So g of 9 equals, everywhere there's an m, you're going to plug in 9. So 5 times 9 plus 17 is 45. 5 times 9 is 45. Plus 17, 8, 9, 10, 11, 12 is 62. So the function g, when m is 9, and that's what this is all meaning, is equal to the output of 62. All right, for B, they're giving us the function g of m is equal to 5m plus 17. So they're wanting us to decide when g of m is equal to 2. So you can just take this whole thing. This is just another way to look at this. You can just take this whole g of m here and say, okay, well, they're making it equal to 2. So that means that 2 is equal to 5m plus 17. There's some of you who told me that you see it better this way. So I want to make sure and give you this opportunity. If you didn't see it this way and you followed my first directions, which was g of m is equal to 2, you would see that these two are the same. So therefore, these two are the same, and you can set them equal to each other. However you see it, go with what you see, because I want to make sure you understand it in the way that you see it. Okay, so we have to solve for m. Please don't think you have to know both ways. We're going to get rid of the 17 first because it's furthest away from m. So negative 17 on both sides, and 17 is currently positive. And I get negative 15. 2 minus 17 is negative 15, is equal to 5m. 5 is attached to m by multiplication, so we have to do the opposite of that, which is division. What you do to one side, you do to the other, and m equals negative 3. So that just means when m is negative 3, so when the function g has m at negative 3, the output is 2. That was what we were looking for. Determine m when the function g of m is equal to 2. All right, I'm going to stop this video and then I'll go to the next one.